Day 5, solving and representing inequalities. All right, let's start with the warm-up. So we're going to multiply 5r minus 5 equals 2r minus 8 minus 6. Okay, then combine. DCM is our method. We distribute. Then next is combine. So we combine the like terms. 2r, these are on the same side. So negative 8 and negative 6 is minus 14. Then we move 2r to one side of the equation like so, giving me 3r minus 5 equals negative 14. And we move the numbers over like so. 3r equals negative 9. So divide by 3, we get r equals negative 3. And that's our answer. So remember, combine, that's like when you have two x's on the same side like this. Okay, move is when we have the x's on opposite sides like this. They're two different things, so just be careful that you don't mess them up. Okay, so we're going to start inequalities. An inequality is any statement that two quantities are not equal, i.e. they are greater than, less than, greater than or equal to, less than or equal to. And if you have a hard time mixing, if you mix these up a lot, okay, just know that the less than symbol it's like a slanted L, okay, less than. All right, so here are some examples. X is greater than 5, x is less than or equal to less than negative 4, okay, and all of these has is in them. X is greater, x is less, not to be confused with 5 more than x or anything. We do those expressions a little bit later on. Okay, so this one is just saying that the two are reversible. So if you have 5 is greater than 3, it's the same thing as 3 is less than 5. If you have 3 is greater than x, it's the same thing as saying x is less than 3. For our purposes, we prefer to have the x on the left, just because it's easier to read. Okay, the solution to an inequality, just like with an equation, is a set of numbers that make the equation true. Okay, now here's the thing. If x is less than 5, right? And we go to a blank page. Think of all the numbers that are less than 5. Well, there's a bunch of them, right? If I draw a number line, here's 5. Okay, I can think of 4, I can think of 3, I can think of 2, I can think of 1. I can think of negative 27 if I wanted to. It's down here. Those are all integers, and we tend to think in integers. Let's think about the decimals, 3.3, negative 1.6, and so forth. So basically, it's all the numbers over here. Now, what about 5? Well, 5 is not less than 5, but if I have 4.9, which may be really close to it, oops, down there, okay, that is less than 5. So what do? I put a big open circle on 5 because I'm not counting it, and I'm going to draw an arrow to the left, representing that I'm including all the numbers that are less than 5, and all the numbers that are greater than 5, which is on the other side, like 6, 7, 42 up here, okay, are not going to be shaded. So if it's shaded, it makes it work. It's a solution. Okay, and that's how this is called a graph of the solution, because basically it's just a picture. Okay, so then going back to the lesson, there's 3 solutions and 3 non-solutions to the equality x is less than 5. Well, we already mentioned some. Maybe negative 3, maybe 2, maybe 0. Non-solutions, 27, definitely not. 5, definitely not. And I don't know, 16, not solutions. Okay, and the graph, as we said, we're going to shade all the numbers, and we usually shade above the number line like this. Okay, and we're going to get really close to 5, but not touching 5. So that's what the open circle means. Open circle means not including 5. Okay, So that's why there's an open circle on 5. Now, how many solutions? Well, I just gave you 3. But really, there are an infinite number. And that's different from equations, because equations, they typically will have one solution, except for the ones that are infinitely many or no solutions. But there's like a zillion of them. We need the graph to show that, okay? It's shown on the graph through shading. So it's like only we can draw a picture of the solutions, we can't actually list them. I could list a couple of numbers that I see here, but am I going to get all of them? No, because I have to count the decimals and the decimals in between the decimals, right? Like even here, all the numbers between 3 and 4 are shaded. So I can call that 3.5, or I can keep going, 3.4. Okay, so there's like a bunch of them in here. Even pi's in here if you think about it, right? 3.14 is all the way in there. So I'm thinking of there's a lot of numbers in here that I can't really count. And so that's why there's an infinite number and I don't bother to list them. That's what the graph is for. Are all of them integers? Okay, integers, no decimals. So do they all don't have decimals? Well, the ones I can see here clearly don't. And these are the ones we tend to think of. So we got to think of something else, like we just mentioned one. Okay, no. Like 3.4 is one that's not. Okay, is 5 a solution? No, it's not. How is it shown? With the open circle. Because 5 is not less than 5. It is not a solution. Now, what's the lowest? Well, see this arrow here? That means there is no lowest. No lowest. Now I got something even crazier for you. What's the highest? There's no highest either. Because 5, while it's a boundary, is not in the solution set. But maybe you're thinking, well, what about 4.9? Well, all I have to do is keep adding a 9. 4.99 is higher than that. 4.99 is higher than that. 4.999 is higher than that. So there's actually no highest either. Would your answer change if it was less than or equal to 5? Sure. Then the answer would be 5, and 5 would be the highest. Okay, so the next section has to do with something called interval notation. Okay, an interval notation is a way of representing a group of numbers, an infinite group of numbers, very simply. So what do I mean by an interval group of numbers? Well, remember that graph of x is less than 5, right? That was this. We know that there are zillions upon zillions of numbers in that group. Okay, millions, an infinite number, an uncountable number of numbers. So I can't list them all. Okay, it's not like I can just list the ones I see. It's not like 1, 2, 3, 4, and 5. It goes way beyond that because there's fractions and decimals and stuff. So listing them is not a good idea. So what I have to do is just say, well, where do they begin and where do they end? Hence the interval. An interval is when you say, well, it's from here to here. Okay, like an interval of time. Oh, when's your party? Oh, it's from 4 to 6. Okay, that's an interval. Okay, so it starts at 4 and it ends at 6. So that's what we're going to do, is we're going to describe an interval where numbers start and where they end. So let's just get some common terms down, basically. Okay, so you're going to have a start number and you're going to have an end number. And those numbers are going to be separated with parentheses. Okay, point number 2. They're either going to be surrounded by parentheses, brackets, or a combination of both. Okay, one of each. All right, and each of these things means something. Okay, if you have parentheses, okay, parentheses mean that the interval is open. Okay, and what that means in plain English is you will see one of the following on a graph: an open circle, an arrow, okay, an open circle or an arrow. All of those are going to be open. Okay, brackets mean the interval is closed. What that basically means is that there's a number that you can point at that it stops at. And for those are easy. You'll see a closed circle on that point. Okay, and then so you can have a parentheses on one side and a bracket on the other side. Okay, so now when you are figuring out the start number, this end number, there's also one other thing you have to know. Okay, most of these are going to be a number like 5, but sometimes it has no end. If it has no end going to the right, we're going to write an infinity symbol on that side. If there's no end and it goes to the left, we're going to write a negative infinity symbol on that side. Okay, because that's the positive numbers and that's the negative numbers. Make sense? Okay, so let's just take a simple example and then we'll go back to the page. All right, so my simple example, I know I keep talking about this graph, but here's x is less than 5, right? Well, above the graph, here's how I would do the interval notation. Okay? First, I would write a 5 over the number 5. That's easy, because that's the number 5. Now, over the arrow, remember the arrow means that it continues on forever, but it's going in the negative direction. So, over there, I would write negative infinity. Okay, to do the interval notation, I would take the two numbers that I just wrote, negative infinity and 5, and I would put them together with a comma in between them. And I would also use a bracket or the parentheses. Now, an open circle gets a parenthesis. Okay, that's because it doesn't actually get to 5. All right, now it's not going to get to infinity either. There's an arrow on that side, so I also get parentheses here. Now, if that were a closed circle, that would change to a bracket because it does equal 5. Okay, and this right here is what we call interval notation. Okay, so back in the packet, we are going to first write an inequality for the graph and then put it in interval notation. Okay, so first one here, this is showing all the numbers that are greater than or equal to negative 3. And I know it's equal to because it's got the equal to sign there. So for an inequality, I'm going to write x is greater than or equal to negative 3. Okay, this one is negative 3 also, but it's going down. That's x is less than or equal to negative 3. When there's an open circle, it means I'm not counting the equal to at all. So this is x is just greater than 3. This one, open circle, so, but it's going down, so x is less than 1. And did you know that the symbol, the less than symbol, and the greater than symbol also mirror what kind of arrow you make? So less than symbol, which is this one, will have an arrow pointing to the left. Okay, a greater than symbol, which is this one, will have an arrow pointing to the right. Okay, so now let's do interval notation. So I'm going to get rid of all of this. For interval notation, the easiest way to do that is with the graph. So let's begin. You need to write first where the graph begins and where the graph ends. This graph begins at negative 3 and it ends, well, it doesn't end, it ends in the positive direction, positive infinity. So I start by writing negative 3 infinity together. Now I've got to put the brackets or the parentheses. So I'm going to make it really easy for you. If you see a closed circle on any side, that is a bracket. Everything else is parentheses. So I see a closed circle on the -3, brackets on this side. Okay, that's not over here, so that is parentheses. Okay, now let's do this one. -3 over the number. This is an arrow, but it's going negative infinity. But I have to copy the numbers and symbols exactly in the same order. That's why the graph is so helpful. Are there any closed circles? Yeah, over the -3. He gets a bracket on his side, and he does it. Okay, for this one, this is the number 3. This side is going up forever. That's positive infinity, so 3 infinity. And do I see any closed circles? No, I do not. Parentheses on both sides. Okay, and then this last one, this is going down to the negative direction, so negative infinity. And this is the number 1, right in order. Negative infinity, 1. And no closed circles here, so just write parentheses. So this is called interval notation. It's just a way of expressing an inequality, the beginning and the end of it, in an easier way. Okay, so you're going to write the inequality and interval notation in the graph below. After you finish this, go on to video number 2. Okay, here are the answers. Just check your work. This is the inequality. This is the inequality. This is the interval notation. Okay, go on to video part 2 now.